Hi guys, so this is the last problem that we didn't get a chance to do in class. It is, if you have the PowerPoint slides printed out and you do 3 to a page, it's the last slide on page 8. I'd like to make an announcement now, Doug, that there's a glare that's probably somewhere within this vicinity. Is that right? Okay, good. Somewhere within here, Doug. And I'm not going to hear any excuses or whining or complaining because, Felicia, what did I tell you before?
PowerPoint slides?
Yeah, you should look at your PowerPoint slides since you obviously know that this is in diffraction section, and I can see that this says a particular diffraction grating produces, so you should look at your slides, Doug. Okay, let's read the question. A particular diffraction grating produces an n equals 2. So n equals 2 is one thing that I'm given, and then what does n represent? Order number. So I have n equals 2, that's my order, at an angle of 32 degrees. So there's my theta, and that's for a light with wavelength. So there's my lambda, 500 nanometers. Uh-oh, what's wrong with it? Do I like that? No, so how do I change it? 500 times 10 to the negative 9 meters. Okay, in A, they're asking us how many lines per centimeter does the grating itself have? So they're asking us for that big capital N number. Okay, here's the things that I know. I know my order number, I know my theta, I know my wavelength. There is an equation that represents or relates all three of these things together with another variable. And that is d sine theta equals n times lambda. Okay, well, I have this, I have this, I have this. So if I plugged all those things in, I'd be finding d. But why would that do me any good at all? Because d has a relationship with capital N. And I know that d is equal to 1 over n. So if I find this, I can find this. Okay, so that's why we're using this formula, because once I have this, I can find my number of lines per grating. Okay, so let's plug everything in. So I have d times sine of 32 equals 2 times my wavelength, 500 times 10 to the negative 9th. Okay, so when we do all of this, we'll take those two, multiply them, then divide both sides by the sine of 32. When you do that, we should get, which do you have it?
1.9 times 10 to the negative 6.
Very good. 1.9 times 10 to the negative 6. Now, we changed this to meters, so what unit is this d in? Meters, very good. So I have 1.9 times 10 to the negative 6 meters, but they're asking me first, and let's think about this. How many lines per what?
Centimeter.
Centimeter. Would it be easier to just go ahead and change this into centimeters now?
Yes.
Yes, it would. So let's do that, children. What's the easiest way that I can change this meter into centimeter? Very good. I'm going to multiply by 10 to the second, which is just 100, because there's 100 centimeters in a meter. So if we want to look at that, instead of second guessing, we can just show it. Which one's smaller, centimeter or meter? Centimeter, and I know there's 100 centimeters in 1 meter. So I'm going to take that number times 100. Okay? So once I do that, instead of 1.9 times 10 to the negative 6, I should be left with 1.9 times 10 to the negative 4th. And all I did there was multiply by 100. Okay? So I have d. My goal is to find n. I need this number. And we know up here, d is equal to 1 over n. So I know that d is, let me change that to centimeters. Sorry guys, so that we change that to centimeters. So d is 1.9 times 10 to the negative 4th centimeters. That equals 1 over n. Do we like n in the denominator? No, so what do we do to both sides? Let's multiply both sides by n. What happens here? Cancel. So that means I'm left with n times 1.9 times 10 to the negative 4th centimeters equals 1. What do I do now to get n by itself? Let's divide both sides by the number. And then same thing here. Okay, so we take 1 divided by 1.9 times 10 to the negative fourth. What do we get?
5,263.
Tell me one more time.
5,263.
And that would be lines per centimeter. We're done. So we have A. Okay, so this is the way that they will relate your slit separation and then the number of lines per length of whatever your diffraction grating is, and then this equation. So this is a really good example of how they can relate these two. Okay? Let's work on part B. Part B says, at what angle can the n equals 3 spectral order be seen? Okay, well, we know that our order number is what for part B? We know our order number is 3. We're trying to find theta. What else do I know? What do I know? Okay, I know D is 1.9 times 10 to the negative 6. What else do I know? I know wavelength is what? 500 times 10 to the negative 9. Felicia, what equation would I use? Same one here. Okay, so I'm not going through that because you've done this several times and you know how to do that. On C, what is the highest order maximum that can be observed? How will we do that one? What do we think? Danielle, how much time do we have on that one?
7 minutes.
7 minutes. Okay, we're good. Okay. The reason that I like this question is because you have to look at it visually. You're going to have to draw a picture for this, and there's a reason why. And this goes along really, really well with your homework problem number 39. So that's the last homework problem that you have for this chapter, and it goes along really well with that. So highest order maximum that can be observed. If I have this is my slit, and I have light that's coming in through that slit, and it's going to be projected on a screen. So light's coming through the slit, and it's going to be projected on the screen, okay? So I have, first of all, my central maximum will be right there, because it's at no angle, it's just straight through the slit onto the screen. Then I can have an n equals 1, where that would be my peak at either side. So I could have it at an angle, that's going to be at an angle. So both of those would be equal to each other, but they're going at different ways. That would be my n equals 1. I could have an even larger angle to get my n equals 2. So that would be like from where that first one was, so then that would be an even larger angle. Then I have an even larger angle if I wanted an n equals 3. Do you think that that angle is going to be unlimited, or is it at some point they're going to be cut off? What do you think? There's what? There's going to be a cutoff, and I want us to see why. As I keep coming out this way, I'm no longer going to be projecting on my screen. So at some point, at some angle, I'm no longer going to hit the screen. And actually, it's going to happen that I'm going to be projecting along my slits. So if I'm looking between where I can have my central peak and where my slit is, at what angle is there going to be a cutoff? A 90-degree angle. And the reason that that is a cutoff is because at that point then, all of that light is going to be traveling within or on that slit. So it can't travel past the slit. It can't go back through the slit. So it's traveling like on the slit itself. So it can't do that. So that's why our cutoff is 90 degrees. So when they ask you, what is the highest order maximum that can be observed? That would be where your theta is equal to 90. Okay, so anytime they're trying to ask you, what's the highest order maximum? Or theta equals 90. On question number 39 on your homework, that question is asking you how many order numbers am I going to see on either side of the central maximum? So you can go ahead and plug in that 90 for the angle if you want to, or you can just plug in n equals 1, n equals 2. And then when you get your angles, if it's after it's hit above 90, then you know that's where the cutoff is. So any angle that's above 90, that's my cutoff, and I'm not going to see any more peaks. Okay? So theta here's 90. What else do we know? What do we want to know? We want to know the order number. So I'm trying to solve for my n. What do I know? I know d, and I know my wavelength. So what am I going to use here? Same exact equation. So on this one I'm going to use d times sine theta equals n times lambda. I have my d, I have my theta, that's the highest maximum angle that it could possibly be. I want to know n, I have my wavelength. So we can just plug all of that in. You should get, for your n, you should get 3.8. So you're not going to see a fourth peak. At most, you'll get up to 3 peaks on either side. Okay? If you have questions, you email me tonight. Your test is still tomorrow. Homework is due tomorrow. If you have questions on your FRQs that I gave you today in class, remember I said that tomorrow is the only day that I will be able to answer any of your questions on them. So look at FRQs, study tomorrow, test tomorrow, or study today, test tomorrow. Is that it? Oh, and homework due tomorrow. I think that's it.